Hello everyone, welcome back to our series of lecture for the course Probability and Statistics. So in the previous lecture, we discussed about the discrete type random variable, which was binomial random variable, right? So in this lecture, we'll discuss about the Poisson random variable. And what is that? First, let us see the definition, then we'll try to understand how we'll understand that some distribution will follow the Poisson random variable. So a random variable x that takes on one of the value, it can take 0, 1, 2, and it can goes up to infinity because it do not have any limitation. And it is said to be a Poisson random variable with a parameter lambda if for some lambda greater than 0, p of like the x is equal to I, it is e to the power minus lambda, lambda to the power I by I factorial. And where this I can take the value 0, 1, 2, and there is no limitation. So if some random variable follows this distribution, this is the probability mass function, then you call that it is a Poisson random variable, right? And how do you understand that it will actually gives you it is the probability mass function? So their total sum should be 1, probability sum should be 1, but here you have infinite number of values. But let us see. So we can check that summation of I equal to 0 to infinity. P of x is equal to I. And let's see whether it gives you the value 1 or not. So this one is equal to summation of I equal to 0 to infinity. Let us move this mass function e to the power minus lambda, lambda power I divided by I. So e to the power minus lambda, I can take it common into summation of I equal to 0 to infinity, lambda power I divided by I. But can you realize what is this expression? Summation of I equal to 0 to infinity, lambda power I divided by I factorial. So if you understand that e power x expansion, it is what? 1 plus x square by 2 factorial plus x cubed by 3 factorial plus dot 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 like this. So it is what? It is summation of x is equal to 0 to infinity. What is that? X to the power I divided by I factorial, right? So if that is the value of e to the power x, so what is this value? This green shaded one. So I have written it as k, but it should not be k, it was lambda, right? So it was e to the power k, and this value is again e to the power. Again, I did the mistake. It's a e to the power lambda. So e to the power minus lambda, and this value is again e to the power lambda. So it is e to the power minus lambda into e to the power lambda, which is actually 1. Therefore, it is verified that this one is a probability mass function of some random variable. In this case, it is the Poisson random variable. Got it? So we will do several example. We'll understand several example also. Before that, I just wanted to calculate the expected value of this random variable, and then I'll come back to the examples, right? Because there is a reason. So first, let us understand what is the expected value of this random variable, Poisson random variable. So this is the probability mass function, and we'll calculate its expected value. So how we calculate the expected value? E of x is equal to summation of I into small p of I, because we are taking in this way. So this is basically summation of I into e to the power minus lambda into lambda power I divided by I factorial, where I runs from 0 to infinity. Correct? Now let us do some calculation. Now see again, I equal to 0 value will give you 0. If you put I equal to 0, because of this I, it will give you 0. So I can take the same thing, I can take it for I equal to 1, because I equal to 0 gives you 0. So it is I into e to the power minus lambda, which is actually the probability mass function of Poisson random variable, divided by I factorial. Now what we can do, take one lambda common from this place and take it outside. So it is lambda into summation of I equal to 1 to infinity I into e power minus lambda, lambda power I minus 1 divided by. Okay, one more thing. This I and I factorial is there. Both of them are there, right? So both of them together gives you what? So this I will be cancelled and it will be adjusted in the denominator. It is basically I minus 1 factorial. Correct? Now again we'll change this index. What we'll do? We'll take I minus 1 equal to j, another index. Now if I runs from 1, 2, 3 up to infinity, where j will run? It is runs from 0, 1, 2 up to infinity. Right? So after changing this, we'll get summation of j equal to 0 to infinity e to the power minus lambda, lambda to the power j divided by j factorial. So I'll take lambda into e power lambda minus lambda, I'll take it out, and it is summation of j equal to 0 to infinity lambda power j divided by j factorial. Now again you realize, what is this expression? What is this expression? Just few minutes back we did. Yes, it is e to the power lambda. So lambda into e to the power minus lambda into e to the power lambda, which gives you only lambda. So that is what my point. We have seen that the Poisson random variable is following this distribution, this value, right? That probability mass function is this value. So this is the probability mass function. So e to the power minus lambda into lambda power I by I factorial. So Poisson random variable with parameter lambda. But what is this lambda? It is the expected value. Just now we calculated. This is the expected value, right? And expected value means what? It is the average or it is the mean. We discussed in our previous lectures, some of the lecture. Got it? So in the Poisson random variable with parameter lambda, that lambda is actually the expected value. That means it is the weighted average. Correct? Or it is the mean. Now I'll come back to the example of Poisson random variable. So suppose a call center we have, and then the number of phone calls received by a customer service center in an hour. We want to calculate that. So here somehow we know that the call center gets an average of 30 calls per hour. So we need to calculate that at probability of some number of call in a particular hour. Right? So we only know the average number. So number of phone calls in a particular hour can be anything, we don't know. Right? It can be 0 also, it can be 1, it can be 2, it can goes up to any big number. We don't have any limitation, but somehow we know that the average it gets 30 calls per hour, right? So therefore in this case it will follow the Poisson random variable, because we know that in case of a Poisson random variable, this lambda is actually the expected value. This lambda is basically the average one, right? So therefore this will follow the Poisson random variable. Similarly, we can have few more examples. The number of car accident at a particular intersection in a day. So somehow we know that on an average 5 accident occurs daily. in some junction point. Then the number of accidents per day follows a Poisson distribution. Why? Again, we somehow know the average value. But in some day there may not be any accident. It can be one number of accident also. It can be two number of accident. It can be like there is no certain limitation we have, right? It can be a big number. But we from the previous data we may have collected that okay, average 5 accident daily it happens. So in this case again it will follow the Poisson distribution, and number of accident it will follow the Poisson random variable. I hope you are understanding that how to realize that some variable will follow the Poisson random variable. Okay. Similarly, we have received one. The number of emails a person received in an hour. See, we don't have any idea, right? That okay, somebody used to get in a particular hour, you may get one email, you may get two email, you may get zero email also, or you may get a big number of emails. So there is no particular like limit here, right? How many emails you will get per an hour. But by your previous data, we collected that number of emails received average is 10 emails per hour. Then the count of emails per hour follows the Poisson random variable again. So in its probability mass function is the like its distribution is the Poisson distribution, right? So whenever we have some distribution, we'll see that where you have to do the trial maybe very large number, or the trial may have like the success probability of success may be 0 or 1 or 2, or it can be a very big number where you only know the expected value, you only know the average value. So in this case you will follow the Poisson random variable, right? Because we know that the Poisson random variable, this thing is actually the this lambda is actually the its average value. So therefore, if you know the average, then for a particular time period, what is how many numbers of phone calls or accident or emails, that thing we can able to calculate. Correct? So we have already calculated the expected value. Okay, one more observation. Just observe that in each case, the number of object is very large. Yes, it can be like number of email can be a very big number also in a particular hour. Or number of phone calls in a particular hour can be a very big number. It may be a 0, 1, or it may be a very big number. We don't know. And its probability is also very small because you have a very big number of object. So in other words, if you have n independent trials, each of which result in a success with probability p are performed, then when n is a very large number and p is small enough to make up np is a moderate one. What is that NP? NP was the Bernoulli binomial random variables average, the expected value NP. So this whenever n is a big number, then p will be automatically a small number because the total success is like one time success is p, right? So n into p will be a moderate number. So the number of success occurring is approximately a Poisson random variable with parameter n into p. So the value which will later be shown on that we have already seen, this n into p is the average one, and it is the expected value of the Poisson random variable. Clear? We'll do a few more examples. Before that, let us just calculate the variance of it. So what is the expectation? We have already calculated. It is lambda. Now what is the variance of the Poisson random variable? So we can do the similar type of calculation and we can find its variance. So I'll not do it. I have already. I'll show you. So how to calculate the variance? We all know that variance formula, you can get it with this E of x square minus Ex whole square. So what is E of Ex square? So the same way that summation of I equal to 1 to infinity, summation of I equal to 1 to infinity, I square into e to the power minus lambda into lambda power I by I factorial. That is the probability mass function. And because I equal to 0 will keep this term to be 0, so I can take I equal to 1 to infinity, right? And after that you take 1 lambda to be outside, so it is lambda power I minus 1, and then 1 I we can cancel out with this I factorial, so it is in the denominator it will be I minus 1 factorial, and above 1 I will be there. Now again you change the index j equal to I minus 1. So if I runs from 1 to infinity, j will run from 0 to infinity. So we can easily write down that I equal to j plus 1 and then e power minus lambda, lambda power j by j factorial. And therefore we just separate out this term, we get this one. And but this value is what? It is our expected value, right? Expected value of the Poisson random variable we discussed. And this value we calculated earlier as well. This is the sum of the probability mass function, which was 1, right? And therefore it is lambda times e of x plus 1. But what is e of x? We already calculated it is lambda. So lambda times lambda plus 1. That is e of x square. So just put it in this equation. We'll get lambda plus 1, lambda into lambda plus 1 minus lambda square. That gives you lambda again. So what we understand that in case of a Poisson random variable with parameter lambda, its expected value is lambda, its variance is again the lambda, right? I hope it is clear. Okay, let us do one example. So a vehicle passed through a junction on a busy road at an average rate of 300 per hour. Now see, look at the question. A vehicle passed through a junction on a busy road at an average rate of 300 per hour. So what you know, we only know the average rate. Because somehow you have some previous data, statistical data. From there, one can calculate the average rate. So in a particular busy junction we have. Now, the first question is find the probability that none passes in a given minute. So it is basically counts the number of vehicle passes at a given minute, right? So in a particular time, you may have that the number of vehicle may passes a zero number of also. It is possible, right? In a maybe night time or sometime in a day, it may possible that you may have zero number of vehicle passes. Possible. One number of vehicle possible, two, three, four, and it can be a very huge number of vehicle passes in a very busy time. It may possible, right? So the things is happening, it's a very large number, right? The vehicle pass, it can be zero, number of vehicle passes can be 0, 1, 2, or it can be a very big number. We don't know anything about it. We only know the average rate of its how many vehicle passes. So definitely it will follow the Poisson random variable. So where we have in our hand average thing, so that should be our this average is the expectation, but this expectation is the parameter of the Poisson random variable. Therefore, it will follow the Poisson random variable. Right? Now, how to solve this first problem? Find the probability that none passes in a given minute. So this one is you have to take it as in a minute, right? So suppose x, you take x is the number of vehicle that passes through the junction per minute, right? X is the number of vehicle passes through the junction per minute. Then what is the expected value of this x? So it was given 300 per hour. So what is the expected value of x then? So E of x should be 300 divided by 60, so it is 5 per minute, right? So this is our the Poisson random variables lambda, that parameter. Therefore, x will follow which it will follow the Poisson random variable, and what will be its probability mass function? P of x is equal to I is equal to e to the power minus lambda, which is minus 5, into lambda to the power I, which is 5 to the power I, divided by I factorial, where I is equal to 0, 1, 2, and it can be a very big number. Clear? Now the first question says that find the probability that none passes in a given minute. That means what? Probability of x is equal to 0. What is that? E to the power minus 5 into 5 to the power 0 divided by 0 factorial. Both of them will give you 1. It is e to the power minus 5. So the first problem is done. Now look at the second question. What is the expected number of passing in 2 minutes? See, it is we have that x was the random variable which was the number of vehicles per 1 minute. Now we have to calculate the expected number of passing in 2 minutes, right? So take a new variable which is y equal to 2 times x. So this will calculate the number of vehicle passes in 2 minutes. Then what is the expected number of y? So then e of y is what? So we all know that e of 2 into x. So it is 2 into e of x because it is linear. So 2 into e to the power minus 5. Oh, 1 second, sorry, it is not e to the power minus 5. It is because expected value of x is 5, right? So it's a mistake. It is 2 into 5. So it is basically 10. So the what is the expected number of passing in 10 minutes? In 2 minutes, it is 10. Now what is the next question? It says that find that this expected number actually passes, find the probability that this expected number actually passes through in a given 2 minutes period. So in 2 minutes period, this expected number follows what? So basically, in this case, you have to find the probability of, in this case, you have to find the probability of uh, y equal to 10. In 2 minutes period, this expected value, the probability that exactly 10 vehicles pass in 2 minutes. So we'll have P of y is equal to 10. But what was the probability mass function of y equal to 10? So because expected value of y is 10, so it is e to the power minus 10 into 10 to the power I, but here I is equal to 10, so 10 to the power 10 divided by I factorial, but I is 10 here, so divided by 10 factorial, right? And if you just simplify it, take it to your calculator. If you do the calculation in calculator, you will get it 0.125. You will get this one, right? So this example, we also have solved it. Yes, see, e of x is equal to 1. That is the first answer. And the second part was like x equal to 0, first answer. Then expected value of y, which is 2 times x, is 10. And p of y equal to 10, it is this value. So we got the solution for this question, right? So what we have learned, in some experiment you will do several times, right, where you do your random variable take the number maybe 0, it can take the value 1, 2, and it can take a very big number. So you only know that average value of x, expected value of x. In this case, definitely it will follow the Poisson random variable with parameter of that average, right? So all this content we have mostly taken from this book. some few things we have taken from other references as well. I hope you enjoyed the video. In the next talk, we'll discuss about few more discrete type random variable. We'll meet in the next video. Thank you very much. Bye bye.